In our last video, we have covered on how our KNN works, and today we are going to explore on the real world data sets, how we are going to implement our KNN principles and algorithms. And by end of this video, guys, you should be able to in a position to, at least if somebody will ask, you can explain on how it works, how our KNN works. So that is all our motive is. So let's start with the topic, and before moving ahead, while subscribing, hit the bell icon. Do not forget that, and so that you will not miss the latest updates. Let's start. So here we are with our practical of KNN, and we are going to understand first classification. Then we will talk about regression problem, or how it is solving the regression issue. So here we have taken the wine quality data set. So the first step is what, guys? We have to import our libraries. So these are my attributes, if you see. So my attributes for the data set contains these many, like we have some 13 attributes, and out of that I have alcohol, then malic acid, ash, alkalinity, then magnesium. These are the different chemical formulas for that. And as we are solving our classification problem and we are enhancing this with our cross validation, we are using cross validation, and we are using 10-fold cross validation here, and along with that we are we are tuning with hyperparameter, and we are understanding the accuracy methods for this, like we are creating what is the plot between the actual and predicted, and we are moving ahead. So what is the next step? We have to understand our data set. So this is my head part, and if we'll see how my head is coming up, and my target variable in case of classification is what it is going to be, guys. It's going to be my class, right? And we will see how many classes are present. This is a discrete, this is not continuous. In case of regression problem, we are facing or we are dealing with continuous variables. In case of classification problems, always we have to deal with discrete problems, because we are knowing, okay, which class a particular output belongs, and we are moving ahead. So next is what, guys? Next we have to get our data.info. We have to understand the info part, whether we have any non-null values or not. And one more thing, guys, while working with non-null values also, you are seeing here we don't have any null values, but however, sometimes the data is getting imputed with some other characters, alphanumeric characters, or some kind of characters. So we will not be able to find out during this. We are finding out during our, like when you will start training your model, during that time sometimes we are facing that issue, and we are identifying that we have the symbols or the alphanumeric characters present in that. So we can deal during that time. That's not an issue, because we have not taken our data set till that point, right? So that is one more point I wanted to highlight. So we understood that we have 178 rows present here, okay, and this is my descriptive statistics part. So here all numeric columns we are able to see, and all are numeric columns here. However, then we are understanding whether we have any null values present or not. We don't have any null values. Now we will see whether, in case of classification, one more important factor you have to observe, that whether your data set is containing any imbalanced data. What do you mean by imbalanced data? I have already explained you during our classification video that when a particular class, suppose you have a data set and you have 3 different classes. Those 3 different classes, if each class is containing or distributing equally throughout the data set, that is your balanced class. If your data set is not distributed equally, that is imbalanced class. So here I can see that I have 138, however we cannot divide it equally here. Still there is slightly imbalanced data, because one class, the class 2, is present 71 counts, class 1 is present as 59 counts, and class 3 is present as 48 counts. Then what is the next step, guys? We have to understand the behavior of the data. How we are understanding that? Like we can understand the univariate data behavior, then bivariate data behavior. Bivariate means we are understanding the continuous, how they are, continuous, discrete, how they are, right? And univariate means we are understanding the histogram part or the count plot part. And for class, my class is a discrete variable. So I want to know what is the total count present in my data set, and that we can figure out. And we already understood the count from value counts. The same thing I am defining here in this plot. So you can see I have these many counts. So the maximum count of course is present is 2. The next one is 1. Then we have 3. Then I am understanding the scatter plot between different variables, and I wanted to know the behavior based on hue, because my class is the target variable. So with this I can understand what is the distribution of these 3 classes among my different variables. So first I am understanding, here I have to just understand the chemical distribution, or how the chemicals are present in these 3 different classes, right? So first I am understanding alcohol with malic acid. So for that I have taken hue part, and you can see that I have used my palette. So it is going to give me the color distribution. So if I'm going ahead, you can see that some blue, that one class 1, you can see my class 1 is bit overlapped condition, present in the overlapped condition. However, my class 2 is better, and my class 1 is scattered completely. It's not closely packed, it's scattered completely. So that is my alcohol and malic acid. So if we'll go ahead with alcohol and ash, already I have run these cells because it takes time. So if we'll see the alcohol with ash, here all the classes are not overlapped, I can say. However, for green I can see few things are overlapped here. Green means I have class 3. So that is like that. Then we have alcohol and alkalinity of ash. So with that I can see, this is very important, guys, because with this you can be able to understand, okay, if my new data point will come, how it's going to create neighbors, because we understood what is the concept here in k nearest neighbor. We have to define a k value. Based on that k value, it is going to create clusters among different data points, and those clusters we have to vote like individual clusters or individual groups it is going to create, and from that we are going to go ahead with the majority voting in case of classification. The same thing, just imagine how it's going to be. So to give you that feel, I have taken different classes. I wanted to show you how those data points are getting distributed. Now I have my alcohol and magnesium, right? And if you'll see so if you see that I have all data points are better scattered, it's not problematic. Then we have alcohol and total phenols. I will share all these things whenever I'll get time. Please go through these things at least once. This is alcohol and total phenols. This is how the data is getting distributed among 3 classes, class 1, 2 and 3. Then we have alcohol and flavonoids. Then we have alcohol and non-flavonoid phenols. This is the data distribution, guys. I have taken all. So just to give you that feel how the data is getting distributed. So in case of alcohol and color intensity, I can see that my class 2 is heavily overlapped. So why I'm using this overlapped word, guys, whenever it's going to create clusters, there is a chance based on the distribution of the data, there is a chance that some of the imbalanced or some false negative, right? All those like the predicted like when we'll understand in terms of confusion matrix, there will be true negative, false negative cases will come in this case, right? Because the actual predicted is not going to be the actual predicted, it's falsely predicted. Then we have alcohol and hue. So this is how it's getting distributed. Alcohol, then diluted wines. This is how it's getting distributed. So explore these things, guys. I'm not going to take much time on this. We have so many classes, right? So, and this is my box plot. And I can see that my box plot is, you can see there's no much difference, right? And, my data looks balanced in this. However, just keep a note that whenever you are working with any kind of classification problems, you should always consider scaling the columns, because there is a high chance that if you will not scale it down, the variance, like the the total variance or the residuals and all these things will be more. The consideration point or the consideration factor in classification is, it is always better to scale your data. Or you can create a pipeline, just the way I have shown you during our elastic, that you can create a pipeline and you can move ahead. So this is my heat map. So if you see what is my target value guys here. My target here is class, and I can see that most of the variables are negatively correlated. However, we need to understand the positive one. So 0.44. 0.44 should be my malic acid. Yeah, my malic acid is responsible to determine the class. Then 0.52 we have alkalinity of ash. We have 0.52 that determines your class majorly. Then we have proanthocyanins. So that is going to, again, one more chemical, and that is responsible. Then we have color intensity. That's not much, but yeah, still we have some. So this is my head part. Again, I don't want to run it again. And so if you see that here I'm importing all my libraries. Let us understand what are the libraries we have imported before moving ahead. So the first one is model selection. So inside model selection, I've already explained you that we have all train test split, k-fold, cross-val score. Cross-val score is the one where we can understand the best score of any CV, like cross validation, right? Grid search CV. All we have hyperparameter, that CV, everything is present in your model selection. That's the one thing. Then we have pre-processing. What is pre-processing? Before moving ahead for training the model, we can pre-process the data. That means we are going to normalize or standardize the data. How we are going to do it? We can do it standard scalar. Here I am using standard scalar. If you want, you can go ahead with min-max scalar, but with min-max scalar, there is one chance that there is a chance of getting heavy residues here, because outliers percentage and all these things will be more because of the min and max part. Then because the data is going to be biased when it is coming to the highest points, either to min or to max. So standard scalar is a better one here. Then we have neighbors, k nearest, like we are using k nearest neighbors. So we have k neighbors classifier. That is the module which we are going to import from neighbors. Neighbors is a library inside scalar. So we are using k neighbors classifier. Just remember these words or practice however you feel good. Then what are the classification metrics we understood? We have classification report, confusion matrix, and accuracy score. These are the three things, right? Then then what is the next step? I am splitting my features and target, right? My target is going to be class, and my independent variables are going to be the all variables without my class. So I'm running it. Already these things are there. So I'm just going to show you. Then what is the next step, guys? We have to fit and transform to what? To our training data. We have to just transform our test data, but I'm not moving ahead with that. I'm just showing you the training data. My training data should always be fit and transform. You should not fit and transform the test data, because you do not want your data should be generalized from the starting point, right? You can transform. So what is the meaning of transform? Transform is going to be, it's going to convert. If you are doing fit and transform, that I am telling that, okay, all my data points should understand the behavior of my input data, or the correlation they can understand. So you should not do that with trained data. Then what is the next step, guys? We can understand, or we can implement our KNN. KNN is our model, right? So what is the first point? We have to get my object KNN. K neighbors classifier. I am defining my neighbors. So what I told you, we have a K value. That K value is nothing but your this factor or n underscore neighbors is the one which is responsible to define that. Then we have k-fold. What is k-fold here, guys? I am defining my cross validation here. So I am telling my k-fold, I am telling my, because we are taking 10 folds. So I am splitting my data to 10 folds or 10 different folds. Shuffle, yeah, in between the data it should shuffle to give you the better output. Random state 42, that's fine. Then CV score, I am what I am telling, my cross validation score should input my model. So this is my model, my independent variable and my dependent variable. Then my cross validation I am defining, it's a k-fold. If I'll run this, I am getting all the different values for all different folds. So just let us count whether we have 10 folds or not. So this is one fold. So for one fold we got 94%, which is good. For one fold we got 1. For another fold we got 1. So this is 3. This is 4th. This is 5th. This is 6th. This is 7th. This is 8th. And this is 9th. And this is 10th. So always we need to consider the 10th one. So I can say that overall I got 94.1. And my mean accuracy, what I got? 97.1. That means my model is 97.1% accurate. If we are considering 10-fold. You can try it out with different fold. You can try to use 3 folds and try. You can try with 5 folds and see how your outputs are coming up. Then we can use the hyperparameter, because you need to know before predicting the output or before fitting to the model. We need to know what are the parameters which are better going to respond to the model, right? So for that you should know what are the param grid in this case, because for each model or for each algo, the param grid set of parameters which are going to include are going to be different. So we need to explore everything. For elastic net, I have told you already what are the params. Here we will see what are the params. So my first one, what is going to be x? It's going to be my k value, right? That means my n underscore neighbors. So here I am taking the list between 1 to 20. That means I wanted to try with 1 to 20 different k neighbors. Then I am telling my weights. What is weights? Weights I have already mentioned here. We have 2 type of weights, one uniform, one distance. Uniform means all k nearest neighbors, like all neighbors should contribute equally to the classification, or if one new point will come, it should, like all the data points which are going to create around it, it should be equally responsible or equally contribute to that. That is uniform, and that's a default one when you're considering weights. And you need to remember all the syntaxes, guys. That is the main motive of showing all these examples, so that you can understand why we are doing it and you can remember all these things while practicing. Then we have metric. You know what is metric, right? We are defining the distances. So here I am telling I have 2 different type of distances I am defining, my Euclidean and my Manhattan. So we need to judge each cluster or each group or each neighbors, whatever it's going to create. We need to know which distance it is going to work better, with Euclidean or with Manhattan. Then, so we understood about this uniform, we will understand about distance. So what is distance? So it's not like always your data points are equally distributed, right? There will be high variance between one neighbors to another neighbor. So in that case, distance will come into picture. So it is going to consider, so suppose some data points are near, that means it is going to understand or it is going to predict that value as accurate. However, some data points at distance or having more or far away from that neighbor, they will not consider that. Then we have grid search CV, right? We are defining grid search CV and we know what we need to do, right? We have k neighbors classifier, then param grid, then cross validation, then scoring, right? Then we are defining grid, right? We are fitting our data. And when we are fitting our data, we can understand. Let me run this. So if you run this, you should see which parameter is the best and which accuracy score is better. right? So from best parameters, we understood that my metric or my distance, Manhattan distance, should be good. N neighbors, that means my 11th number of neighbor. Or if I take k value as 11, that means it is going to give me the accuracy, better accuracy. And uniform is the default one which it has considered. Then best accuracy score I got 98 from this. So if I'll use cross validation simple, I'm getting 97. With this, it has improved, right? 98. Now I can understand my best estimator with best KNN, and I am I'm just predicting with best KNN, I'm with K scaled, X scaled, sorry. Then I'm telling my confusion matrix and classification report. Let's understand that. So this is my confusion matrix which I got 59, 69 and 48, and this is my precision and recall which I already explained you how we can read it. Now before moving ahead, we understood for two classes how confusion matrix we can understand. Now we will see how we will read this confusion matrix. So we have three different classes here, right? Class 1, 2, 3. Now each row in this, like take one row, second row, third row. For each row, we are going to define as one class. So first row is going to be class 1, second row is going to be class 2, third row is going to be class 3. So in first row, we have 5900. What it means that 59 values, or the total number of 59 output, 59 count of output, it is predicted correctly as a class 1. And there is no false prediction for class 2 and class 3. Similarly, if we will come to the second row, that means we are saying here 69 correctly predicted class 2 output it has given. However, one false prediction for class 1 and one false prediction for class 3. That means out of total, it has predicted wrong, one output predicted wrongly as class 1 and one output predicted wrongly as class 3. Then if we will come to the third row, that means we have 0048, 48 correctly predicted class 3. There is no wrong or no false class 1 and class 2, perfect prediction, I could say. So this is my accuracy score. Like whatever the accuracy scores I have, I'm just getting the actual and predicted here. So we have different folds, right? We have different folds or different k values. So for those different k values, these are the different accuracies. So we can, if we see that if my k value is 1, I am getting 9.942. If it is 2 or 2.5, I think it's 2, then we are getting less. Then if I'll say that if you'll see here, from this image itself, if you'll see that we are getting, because we have taken from 1 to 20 or 0 to 1 to 20, so this is the output we are, or this is the accuracy distribution how we are getting among that different k values. And we can clearly see that the best one or the best predictor which it has taken, it's correct. Like we have taken 11, right? K. So that value we are getting almost good here, right? So this is how we can understand our prediction and all. And if you want, you can go ahead and create a plot between your errors and an actual, or I can say the residuals and the actual outputs, right? So we will meet during our next video, guys. See you till that time. Bye. That is all for now. We will cover the further classification I'll go in our upcoming videos, and we will understand them. So if you really like the content, guys, please go ahead and start subscribing, like, share your comment, share your feedback, share this channel link to all your friends, and while subscribing, do not forget to hit the bell icon so that you will not miss the latest updates. So that is all. We will meet again. Thank you.